So our today's topic is elementary transformation and inverse. Elementary transformation means how can we apply the transformation in a given matrix. That is called an elementary transformation, means these are the elementary, and we'll cover today. The next topic is inverse, means how to find out the inverse of a particular given matrix. First we have several elementary transformation that we can use for finding an inverse also, or just to find the determinants or anything for the given matrix, or we can reduce the size of the matrix. So elementary transformation is a very important concept of matrix. Though our first elementary transformation is that first one is interchange of ith and jth rows, means we can interchange any given row. Suppose any matrix is given 1 2 3 4 for example, so we can interchange this also. It will be 3 4 and 1 2, and we write to describe this, we'll write that we change R1 with R2. So this is a first elementary transformation for a given matrix. We can apply this for finding anything, maybe it's a determinants, maybe it's a cofactor, or finding the inverse also, or reducing the size of a given matrix. Then our second transformation is ith row is multiplied by k. K means a constant, means we can multiply this given row by a constant number. We can use this also. Suppose we can take this matrix and we have to multiply this first row by any particular constant, then we can write it as R1 3 R1. What does it mean? It means that we multiplied each and every element of the row first with a constant 3. So it will be transformed. If we multiply by it 3, 3, 6, 3 and 4. So this is the way how we can use this transformation. Ri transformation is K Ri. Then our third transformation is K times jth row is added to ith row, means we can use this transformation also. We can write it as Ri plus K Rj. Ri plus K Rj. Means what we have done here, we take the transformation in the ith row and we multiply the jth row by a constant k and we add on in this. We can use this transformation. Suppose we can take example of this matrix also, 1 2 3 4, and suppose we are applying a transformation that we did a transformation in row R2. R2 equals to R2 plus 3 R1. We can use all these elementary transformation in case we are finding the inverse also. So what does it mean? That we did the transformation in the row R2. That means R1 is unchanged. 1 2, we take the transformation in R2, we write the element of R2 plus, that is 3 4, and 3 R1. 3 R1 means we multiply the row R1 by a constant 3, that is 3 and 6. If we add on this will be 3 and 3 6, 6 and 4 10. So the given matrix is now changed in this matrix after applying this transformation. This transformation is it indicating that we have applied a transformation in row R2. So you have to take care of this, that row R1 is remain unchanged. You will never change the element of R1 if you are applying the transformation in some other row. So this is our elementary transformations that we can use, as I have told you earlier, we can use it in reducing the size, in finding the inverse, or in finding the determinant and all that. So these are the transformation, as you can see, these are all for the rows. Same transformation we can apply for the column also. That will be, if we are applying the same transformation for column, so our first transformation will be that any of the column can be interchanged. We can interchange any column. Second transformation will be that if we apply the transformation in column Ci, we can multiply any constant, say k, in any column. Means any particular column can be multiplied by any constant. And our third transformation will be that Ci plus k Cj. What does it mean? That we apply a transformation in ith column and we multiply the jth column by a constant k and we add that. So these are basically the three transformation that is similar for column also. So we can apply wherever we find it fruitful, that we can apply this also. So you can go for the column transformation also. So these are the basic elementary transformation. Now we are moving toward our next topic, that is inverse. What is the inverse of a matrix? If A and B are square matrix such that AB equals to BA equals to I, then B is called the inverse of A. Means if we have two matrix AB equals to BA, it means I. If we get such a condition, then B is called the inverse of a matrix A. Inverse of a matrix A is unique and it is denoted by A inverse. This is the symbol for inverse, and one should you can note that it is unique. Now we take some example how we can find the inverse, and inverse we can find by on the basis of elementary transformation, whether we can apply it for row as well as for the column. Now we take some example for inverse. Using elementary transformation, find the inverse. Means it is well known thing that we have to apply the elementary transformation only for finding the inverse. Our first example is 1 minus 1, and then we have 2, 3. So accordingly to the procedure, we'll put this matrix to the identity matrix and into A, and we'll move in the L direction accordingly for making this a unit matrix. So first we have the transformation for R2, that is we apply the transformation as R2, that is R2 minus 2 R1, and we have to apply the same transformation in right hand side also. So for this transformation we have 1 minus 1, 0 and 5. This is the transformation, and we have to apply the same transformation in the right hand side also, that is 1, 0 and minus 2, 1 into A. So our first concept is clear, that is 1, 0 and minus 2 and 1. The next what we have to do, we have to make this as 1. So our other transformation will be R2 is R2 upon 5. That will be 1 minus 1, and this will be 0 and 1. The same transformation we will apply here also, that will be 1, 0, minus 2 by 5 and 1 by 5. So this is 1, this is 0, this is 1, and the last will be that we have to make minus 1 as 0 for the complete identity matrix. So our next transformation will be in R1, of course, that will be R1 plus R2. If we'll add this two row, this element automatically, this will be 0. So 1, 0 and 0, 1. We'll apply the same transformation in the right hand side also. That will be 3 upon 5 and 1 upon 5 minus 2 upon 5 and 1 upon 5. So what we can conclude here, that this is an identity matrix and this matrix will be the inverse of the given matrix. So this is the way how we can find out the inverse of a given matrix. So the next example is, we have to find the inverse and the matrix given is A equals to 2, 1 and 4, 2. 2, 1, 4, 2. So accordingly to the procedure, we put this matrix to the identity matrix, that is 1, 0, 0 and 1 and into A. The rule is very clear. We have to make this matrix as a identity matrix and we have to apply the same transformation on the right hand side, and finally we have the inverse of the matrix. So what we have, first we'll operate for the R2. First we make the operation in R2, that is R2 is R2 minus 2R1. We finally make this operation. So we have 2, 1 and 0, 0, and the same transformation we will apply for the right hand side also. Then we get 1, 0 and minus 2, 1 into A. Now we can see here that the row R2 is 0. All the element in the second row is 0. So in second row of the left hand side, each element 0, that means A inverse does not exist. You can write here A inverse does not exist. Is it clear? If we find a situation like this, because it is also reducing the size of a matrix, that means for this situation A inverse does not exist. So you can simply write, no need to go further, just write that A inverse does not exist for this condition. Thank you.